So this back side of our review starts off with, what about maxes and mins? Okay, so the maximum is where your graph changes from increasing y values to decreasing y values, right? That's the top of your downward facing parabola, right? Concave down, the top of a concave down. So your y values are increasing to the top, and then they start decreasing as they go down. Okay, so a maximum is where your y values change from increasing to decreasing. And a minimum is where your y values change from decreasing to increasing, right? At the bottom of a concave up parabola, we have a minimum because your y values go from decreasing, and now your y values are increasing. So the maximum is where increasing changes to decreasing of y values, and the minimum is where your decreases changes to increases. Now your zeros, that should be a fairly familiar concept. That's where your graph crosses or touches the x-axis. Okay, it's where the y values are 0. So we say f of x equals 0. It's where your y values are 0, and that happens on the x-axis. Okay, so here is a graphical example. It can either cross the x-axis or it can bounce at the x-axis. So both of these places, in fact all three of these places, we're going to have zeros of your function. Okay, polynomial inequalities. So this is what we just got doing in class, and probably the most the mathematically difficult of all the concepts. So we want to know a couple of things. When is our graph f of x greater than 0? So that means when is our graph above the x-axis? And it's always going to be an interval. And we're going to find the interval where our graph is above the x-axis. So an x1 and an x2. Right, those are your intervals. Or we want to know where our graph is negative. When is it below the x-axis? Okay, if f of x is less than 0, we're talking about when is the graph below the x-axis. On what x interval is that happening? Or we can talk about when is our function on the x-axis, right, equal to 0. Okay, so there were some steps to do this. Number one, we had to solve the polynomial. What are the solutions? So x equals a and x equals b, right? Two numbers, those are numbers that you get when you have your equation, right? We don't have an equation right now, but we have those solutions. Okay, the next, you put them on a number line and we do a sign analysis. Okay, so you put your a and your b on the number line. So maybe a is less than b, we'll say that. Right, and we are creating intervals. We have now made everything to the left of our x equals a, and then we have everything between, and then you have the interval on the outside. Okay, so we have three intervals to test in our equation, right? We don't have an equation per se for this, but then we're going to test your numbers. So you plug in values in each interval to test its positivity, whether it's a positive number or a negative number. Okay, that's what we're doing with this. We're testing for positivity. Is it positive or negative? So we pick some number less than a, right? We pick a number in there and you plug that into your equation. And maybe that came out to be a positive number. Okay? You pick a number in between a and b and you plug it back into your equation. Maybe that was a negative number. I don't know. I don't have an equation. Right? We pick a number greater than b and we plug it in to your equation to see if you get a positive or negative, right? These are your options. And then we want to see, right, where is your graph maybe above the x-axis? So we write down the interval. If we were looking for where is our function greater than 0, Okay, that happens from negative infinity to a, right? And then it happens again from b to infinity. So your answers for a polynomial inequality are always intervals. Intervals where the graph is above the x-axis or intervals where the graph is below the x-axis. Okay, those take the most amount of work. Okay, the degrees. Well, the degree of your polynomial depends on its form. What if we have it in factored form? Okay, we have it with a bunch of parentheses. Okay, that's one of the forms where you're going to see your polynomial. Well, if it's factored, your degrees come from the sum of your powers. We add up the powers to tell you what the degree is. Okay? But what if your thing is already in standard form? Okay, that would be like ax to the 7th plus bx to the 4th plus cx squared, whatever, right? All these random ones. Well, if it's already in standard form, then your degree comes from the highest power in your polynomial. Okay? So the degree of your polynomial depends on how it's presented to you. If it's factored, you add up all your powers. If it's not, then you look at the highest power. And we had 3 different types of multiplicities. Remember, the multiplicity comes from the power of your factor. So if we had a multiplicity of 1, then the graph crossed the x-axis normally. Okay, normal crossing of your x-axis. Nothing strange is happening if there's only one solution. If we had a multiplicity of 2, that means your graph would bounce. Or just touch the x-axis, right? It would not actually cross. It would go from positive to positive or from negative to negative. And then our third option was if we had a multiplicity of 3. And at that time, the graph crossed, but very, very flat. The graph flattens where it crosses your x-axis. So let me give you an example of each of these. Okay? So here would be a bounce. This would be a bounce, right? The graph touches the x-axis and then comes back down. This would be a cross. The graph crosses the x-axis completely normal, right? What we would say is normal. And then if the graph were to come in like this and then flatten as it crosses, that's a multiplicity of 3. Okay? A bounce, a cross, and a flatten. Those are your 3 types of multiplicities and their graphical implications. And our last concept was complex zeros. So remember, our complex zeros always come in a yin and a yang kind of business. Okay? If we had 7 minus 3i as your original x value, then its conjugate would be 7 plus 3i. Okay? And these always come from an x squared type of a function. Okay? Because you don't get a imaginary number unless you are dividing by or taking the square root of a negative. Okay? So remember, these are called conjugates. That's a vocabulary word. That one is a positive and one is a subtraction, right? Those two are conjugates of each other. So the test, you'll have 8 multiple choice questions with no calculator, and you'll have 1 free response question, calculator allowed. Okay, so look over your homeworks, look over the notes. If you want to go to AP Classroom, hopefully you signed up for that. Okay, there's a progress check over Unit 1. That might help you out with some similar type problems to what you'll see on your test tomorrow. Hope this helps.